Now we need to talk about the EMF of the cell. We've already been kind of using the EMF of the different half reactions to decide which side is going to be oxidized and which side is going to be reduced. Now let's talk about the actual EMF of the cell. It's a definition of the EMF. We've actually mentioned it before when we were doing electric circuits. The EMF is the maximum amount of voltage that a cell can provide a circuit, right? Similarly, the EMF of the cell is defined as the maximum potential difference between two electrodes or half cells in a galvanic cell. And why do they say it's the maximum? Well, because it's the minute you put the two electrodes in contact with each other in a circuit, the minute you close that, okay, it starts giving off electrons, which means the EMF is immediately going to start decreasing. So therefore, the EMF is the maximum potential difference that can occur between two electrodes before we actually connect it. Now, it's very important to be able to calculate the EMF of the electrochemical cell. Guys, think about it this way. Every battery you've ever used in your entire life actually has a voltage on it, okay? It's either 1.5 volts or a 3 volt or a 2 point whatever volts or a 12 volt battery, etc. And that's actually the EMF. So the way that they get these different battery sizes or amount of voltages, there are two ways. One is that they can make, like a car battery is actually made up of 6 cells, okay, each given of 2 volts, which gives you a battery of 12 volts. Because a battery, officially, a battery is 2 or more cells connected, okay? A cell being one galvanic cell. Okay, so now, as you guys know, and as I've mentioned before, it totally depends on what is in your cell as to how many volts given off, okay? So if I want a really high-powered battery, I'm going to choose something like lithium at the top here and fluoride at the bottom to give me a potential voltage of 6 volts, okay? Almost 6 volts. Whereas if I choose something like, I don't know, iron over here and copper over here, do you see that that gives me, what is that? That is minus 0.04, and that's about 0.2 volts, which is ridiculous. But if you only want 0.2 volts to run something with a very small battery, then you need that. So that is why it's important to be able to calculate the EMF. So there are 3 different reactions that are all on your formula sheet. And they are very important. That E theta, and I call this E theta, a lot of teachers call it E0, or let's call it the EMF, but it's E theta of the cell is going to be the E theta, or the EMF of the reduction half reaction, minus the EMF of the oxidation half reaction. Or it can be the EMF of the oxidizing agent minus the EMF of the reducing agent. Or it could be the EMF of the cathode minus the EMF of the anode. Guys, these are all the same thing. It just depends on which way you look at them. And the reason why it's cool that they put this on your exam papers, because sometimes students forget about red cat and anox. Okay, they forget about anox and they forget about red cat. So they forget that the cathode is where reduction occurs, and they forget that an anode is where oxidation occurs. I mean, I can understand it if you're tired, it's been a long exam period, and science, chemistry is one of your last papers. It might be difficult to remember everything that you've studied, unless you've been studying for a long time and revised a lot. So it can happen that you can forget that. And that's fine, because on the formula sheet, they've got that the EMF for the reduction half reaction minus the EMF for the oxidation half reaction is the same as the EMF for the cathode minus the EMF for the anode. Okay, and just to really make it easy for you, that is exactly the same as the oxidizing agent minus reducing agent. So there you go. They've actually given quite a lot of information on the formula sheets, and that's sweet of them. So for a zinc cell, zinc copper cell, okay, if we're going to look for zinc copper, okay, there's your zinc, okay, and your copper, which is going to be Cu2 plus 2 goes to, there it is. Okay, so the value here is minus 0.76, and the value here is 0.34. So if you're using table 4b, it is always the bottom minus the top. Always the bottom minus the top. Okay, if you're not, then you need to know that it's the cathode minus the anode, the oxidizing agent minus reducing agent, the reduction half reaction minus the oxidation half reaction. Okay, you also know that this is going to be the reduction half reaction because it's lower than this one over here. So therefore, we can say that this is 0.34 minus 0.76, which is 1.10 volts. And what does that mean? That means that this reaction is spontaneous. Because if this is bigger than 0, then this is a spontaneous reaction, EOUS, spontaneous reaction. But we'll speak about spontaneity later on. Okay, so let's talk about standard EMF. The standard EMF is called E0, and the E0 of the cell is the EMF of the galvanic cell operating under standard conditions. So that's 0 denotes standard conditions, and the standard conditions are the temperature has to be 297 Kelvin, the pressure is 1 atmosphere, and the concentration is 1 mole per decimeter cube. Now let's think about this. Remember we're talking about rates of reaction the other day, rates of reaction. And we spoke also about chemical equilibria. And we said that there were a couple of things that affected this. Okay, first of all, rates of reaction, temperature. Do you agree? What else? Pressure or concentration or both, depending. Then there's rates of reaction would be a catalyst. Surface area. Okay. Yeah, chemical equilibrium, it's obviously temperature. Okay, what else? The pressure or the concentration. Okay, and those are really it. Temperature, pressure, concentration. Yeah. I mean, you can also, yeah, like you can know this fine. So do you see that these things here affect the rates of reaction and also the chemical equilibrium? And that is why these things have to be kept constant in order to get the E theta. If you want these values here, minus 3.04 for this against, and remember this is with respect to the hydrogen electrode, then in order to get that, these must be constant. And grade 12, they love actually asking that. It's a very nice exam paper question. They'll say, Johnny did the experiment where he was looking to try to find out the voltage of the copper zinc battery. And he found it to be 0.89 when it's supposed to be, for example, 1.04. What could he be doing wrong? And it could be that his temperature is not correct, that the concentration of the electrolytes are not 1 mole per decimeter cubed, that the pressure is not 1 atmosphere. So those are three of the things that could be wrong for dear old Johnny.